How did the universe come into existence? The origin of the universe has been the subject of scientific investigation, philosophical inquiry, and cultural narratives for millennia. There are several theories and hypotheses about how the universe was formed, with the Big Bang Theory being the most widely accepted among scientists. Here are some of the main theories and hypotheses. Big Bang Theory. The Big Bang Theory proposes that the universe began as an incredibly hot and dense point known as a singularity approximately 13.8 billion years ago. It then rapidly expanded, and space itself has been expanding ever since. Inflation Theory. The inflation theory suggests that the universe underwent a rapid and exponential expansion just moments after the Big Bang. This inflationary phase helps explain certain features of the cosmic microwave background and the large-scale structure of the universe. Cyclic universe theory. Some theories propose that the universe goes through an eternal cycle of expansion, contraction, and rebirth. This means that after each big crunch, contraction, a new Big Bang occurs, leading to a new cycle. Multiverse hypothesis. Multiverse hypotheses suggest the existence of multiple universes, each with its own physical laws and constants. These universes may exist independently or interact with each other. Creation myths and religious beliefs. Many cultures and religions have creation myths and beliefs that describe the origin of the universe as the result of divine or supernatural processes. These narratives vary widely among different cultures and belief systems. It's important to note that while the Big Bang Theory is the most widely accepted scientific explanation for the universe's origin, it does not address what, if anything, existed before the Big Bang or what caused the Big Bang itself. These questions remain subjects of ongoing scientific inquiry and philosophical contemplation. Additionally, theories like inflation, cyclic universes, and the multiverse are still subjects of active research and debate within the scientific community. Big Bang Theory. The Big Bang Theory is the prevailing scientific model that describes the origin and evolution of the universe. It proposes that the universe began as an extremely hot and dense singularity approximately 13.8 billion years ago and has been expanding and evolving ever since. Here are the key points of the Big Bang Theory. Singularity. The theory posits that the entire universe, including all matter and energy, was once concentrated into an infinitesimally small and hot point called a singularity. At this point, the laws of physics, as we know them today, break down. Expansion. Around 13.8 billion years ago, this singularity suddenly and rapidly began to expand. It's important to note that the term Big Bang is somewhat misleading. It wasn't an explosion in space but rather the sudden expansion of space itself. Cosmic microwave background, CMB. As the universe expanded and cooled, it entered a phase where protons and electrons combined to form stable atoms, primarily hydrogen. This release of energy, known as recombination, left behind a faint afterglow of radiation known as the cosmic microwave background, CMB. The CMB, discovered in the 1960s, is one of the most critical pieces of evidence supporting the Big Bang Theory. Formation of matter. As the universe continued to cool, protons, neutrons, and electrons combined to form the first atoms. These atoms were primarily hydrogen and helium, which serve as the building blocks of matter. Galaxy formation. Over time, matter clumped together due to gravitational forces. These clumps of matter eventually formed galaxies, each containing billions or even trillions of stars. Star and planet formation. Within galaxies, gas clouds collapsed under gravity to form stars. These stars, in turn, often had planetary systems of their own, where planets formed from the leftover material. Continued expansion. The universe continues to expand to this day. Observations have shown that galaxies are moving away from each other, indicating this ongoing expansion. The Big Bang Theory is supported by substantial evidence from various fields of astrophysics and cosmology, including observations of the CMB, the observed expansion of the universe, the abundance of light elements, and the large-scale structure of the cosmos. It provides a coherent framework for understanding the universe's origin and evolution, although it doesn't address the question of what might have caused the initial singularity or what, if anything, existed before it. These questions continue to be subjects of scientific exploration and inquiry. Inflation theory. Inflation theory is a cosmological hypothesis that proposes an early phase of extremely rapid and exponential expansion of the universe just moments after the Big Bang. This theory was developed to address several key issues and observations in cosmology that the standard Big Bang theory alone could not explain. Inflation theory was first proposed in the 1980s by physicists Alan Guth, Andre Linde, and others, and it has since become a widely accepted part of modern cosmology. Here are the key points and implications of inflation theory. Rapid expansion. According to inflation theory, the universe underwent a period of incredibly rapid expansion, often referred to as cosmic inflation, during the first tiny fraction of a second after the Big Bang. This expansion caused the universe to increase in size by an enormous factor in an extremely short amount of time. Horizon problem. One of the primary motivations for inflation theory is the so-called horizon problem. This problem arises because regions of the observable universe that are separated by vast distances appear to have similar temperatures and properties. In the standard Big Bang model, it would be unlikely for these regions to have had enough time to reach thermal equilibrium and exchange information, given the finite speed of light. Inflation solves this problem by allowing these regions to have been in contact before the rapid expansion. Flatness problem. The universe appears to be very close to flat, meaning that it has nearly zero overall curvature. In the absence of inflation, the universe's curvature would have to be finely tuned to an extremely precise value to explain the observed flatness. Inflation naturally leads to a flat universe, as it smooths out any curvature. Origin of structure. Inflation provides a mechanism for the formation of large-scale structures in the universe, such as galaxies and galaxy clusters. Quantum fluctuations during the inflationary phase are stretched to cosmic scales, leading to the initial density fluctuations that serve as the seeds for structure formation. Cosmic microwave background, CMB, inflation theory predicts the existence of a pattern of small temperature fluctuations in the cosmic microwave background radiation, which is a relic of the Big Bang. These temperature fluctuations have been observed and are in excellent agreement with the predictions of inflation. Evidence and confirmation. While inflation theory remains a theoretical framework, several pieces of observational evidence support it, including the CMB data and the large-scale distribution of galaxies. The discovery of gravitational waves in the CMB by experiments like BICEP-2 and the Planck satellite has provided further and direct evidence for inflation. Different inflationary models. There are various inflationary models proposed by physicists, each with its own set of predictions and consequences. These models differ in their details but share the overarching concept of an inflationary phase in the early universe. In summary, inflation theory is a widely accepted cosmological framework that addresses several long-standing problems in the standard Big Bang model. It proposes that the universe underwent a period of rapid expansion, leading to the structure and properties of the universe as we observe them today. While it has garnered substantial support from observational evidence, ongoing research aims to refine the theory and explore its implications further. Cyclic universe theories. Cyclic universe theories are cosmological models that propose a cyclic or oscillatory nature for the universe, where it undergoes an infinite series of expansions and contractions. These theories aim to address some of the unanswered questions and problems in cosmology, such as the origin of the universe, the nature of dark energy, and the ultimate fate of the cosmos. There are several variations of cyclic universe theories, but the most well-known one is the ekpyrotic universe, or Brane cosmology, model. Here's an overview of cyclic universe theories and the ekpyrotic model. Cyclic universe theories. The central idea behind cyclic universe theories is the concept of an eternal, cyclic process of cosmic evolution. In these models, the universe doesn't have a single beginning and end but instead goes through an infinite series of cycles, each consisting of an expansion phase followed by a contraction phase. These cycles may be triggered by various mechanisms. Ekpyrotic universe, Brane cosmology. The ekpyrotic universe model is one of the most famous cyclic universe theories. It was developed as an alternative to the Big Bang theory and proposes that our observable universe is a three-dimensional, Brane, short for membrane, floating in a higher dimensional space. According to this model, the cyclic process is driven by the collision of two such branes in the higher dimensional space. Brane collision. In the ekpyrotic model, the cycles begin with the collision of two branes in higher dimensional space, causing a release of energy. This collision serves as the trigger for the expansion phase of the universe. Big Bang and expansion. The collision leads to the creation of a hot, dense universe, similar to the initial conditions of the Big Bang in standard cosmology. This universe then undergoes a period of expansion and evolution, much like the observed universe. Contraction and repeat. Eventually, the universe's expansion slows down, and it enters a contraction phase. During this phase, the universe becomes cold and empty. However, the theory suggests that another collision of brins will occur, initiating a new cycle, and the process repeats indefinitely. Multiverse theories. Multiverse theories are speculative ideas in cosmology and theoretical physics that propose the existence of multiple universes or parallel universes beyond our observable universe. These theories have gained significant attention and popularity in recent years, but it's important to note that they are still largely theoretical and have not been proven or observed directly. There are several different multiverse theories, each with its own set of ideas and implications. Here are some of the most well-known multiverse theories. Many worlds interpretation, MWI, of quantum mechanics. MWI suggests that every quantum event with multiple possible outcomes results in the creation of multiple parallel universes, one for each possible outcome. This interpretation was proposed to explain the strange behavior of quantum particles, where they can exist in multiple states simultaneously until observed. In MWI, all possible outcomes occur in separate universes, leading to a vast multiverse of branching timelines. Bubble multiverse. Inflationary multiverse. This theory is based on the idea of cosmic inflation, which suggests that the universe underwent rapid expansion in its early moments. In this theory, different bubbles, or regions of space can stop inflating at different times, creating isolated pocket universes within a larger, inflating space. Each of these bubble universes can have different physical constants and laws of physics, making them potentially very different from our own. Parallel universes in string theory. String theory, a theoretical framework in particle physics, proposes the existence of multiple dimensions beyond the familiar three spatial dimensions and one time dimension. These extra dimensions can give rise to a vast landscape of possible universes with different configurations of particles and forces. The string landscape theory suggests that our universe is just one of many possible configurations of strings in these extra dimensions. Multiverse via black holes. Some theories suggest that black holes could lead to the creation of new universes. These baby universes would branch off from our own universe through the extreme conditions inside black holes. This concept is closely related to the idea of a white hole, which is a hypothetical region of spacetime where nothing can enter, only exit, possibly into another universe. Simulated multiverse. This idea posits that our universe is a simulation created by an advanced civilization or entity. If true, it could imply the existence of other simulated universes or multiple layers of reality created by different simulations. It's important to emphasize that these multiverse theories are highly speculative and have not been confirmed through empirical evidence. They often rely on complex mathematical models and theoretical physics concepts. While some aspects of these theories are consistent with current scientific understanding, they also pose many challenges and questions that have yet to be resolved. The search for evidence of these multiverse theories continues to be a topic of active research and debate within the scientific community. Creation myths and religious beliefs. Creation myths and religious beliefs are fundamental aspects of human culture and spirituality. They provide explanations for the origin of the universe, the earth, and humanity itself, offering insights into the values, beliefs, and cosmologies of various cultures and religions. Here, I'll provide an overview of creation myths and religious beliefs from different parts of the world. Abrahamic religions, Judaism, Christianity, Islam, Genesis, Judaism and Christianity. The book of Genesis in the Bible describes the creation of the world by God in 6 days. Adam and Eve, the first humans, were created on the 6th day. Islamic creation. Islam shares a similar creation story with the Abrahamic traditions but has some differences in detail. The Quran provides an account of God's creation of the world and humanity. Hinduism. Brahma and Vishnu. Hinduism has various creation myths. One common myth involves Lord Brahma creating the universe, with Lord Vishnu preserving it and Lord Shiva eventually destroying it to begin the cycle anew. Purusha Sukta. Another myth from the Rigveda describes the creation of the universe from the cosmic being Purusha. Buddhism. Buddhist cosmology includes ideas about different realms of existence and cycles of birth, death, and rebirth. While Buddhism doesn't focus on a traditional creation myth, it addresses the fundamental question of existence and the cycle of suffering. Indigenous religions. Indigenous cultures often have creation stories rooted in their connection to the land and nature. These stories vary widely from one culture to another and may involve the actions of gods, spirits, or animals. Chinese mythology. Chinese creation myths involve figures like Pangu, who emerged from a cosmic egg and created the world by separating elements like yin and yang. African traditional religions. African creation myths differ greatly among ethnic groups. Often, they involve a creator god or gods and the shaping of the world, including the creation of humans. Norse mythology. Norse mythology features the creation of the world from the body of the giant Ymir and the emergence of the first gods, like Odin and Thor. Greek mythology. Greek mythology has several creation stories, with the most famous being the Theogony, describing the birth of the gods and the world's creation by deities like Gaia, Earth, and Uranus, Sky. Native American religions. Various Native American tribes have their own creation stories, often involving the actions of spirits, animals, or natural elements in forming the world. These creation myths and religious beliefs serve as a foundation for the moral, ethical, and spiritual framework of their respective cultures. They provide answers to existential questions, offer guidance on how to live, and connect individuals to their cultural heritage and spiritual traditions. It's important to note that within each religion or culture, interpretations of creation myths can vary, and beliefs may evolve over time.